Okay, so I'm gonna go over number 1 on the final review problems. And here's another cheat sheet that I made. So we're gonna encounter these 5 symbols, and it's gonna be big omega, big O, theta, small o, and small omega. And to the left of all these symbols are the signs that refer to their symbols. So we have big omega, which is going to be greater than or equal to. Big O is going to be less than or equal to. Theta is just going to be equal to. Omega is going to be less than, and small omega is going to be greater than. And this just means, for this one, this just means the left-hand side is going to grow faster than the right-hand side or equal to. Same with the big O and vice, etc. And then here, just some reminders that polynomials grow faster than logs, and exponentials like 2 to the x will always grow faster than polynomials like x squared. And then here are some log definitions that I think are important to remember for the test. So now I'm going to go and start on problem 1a, which is n square root of n is equal to big omega n squared. And we can rewrite this by doing this. And then we look at the symbol, which is big omega, and that is greater than or equal to. So we can replace this with greater than or equal to. So now we just see if this statement is true. So we can simplify this further. It could be n times n to the 1/2 if that's equal to greater than or equal to n squared. And then we can multiply this. So we just add, which would be n to, turn this to a 2, 3 over 2. Sorry, let me fix this. Okay, and so that's going to be, is that greater than or equal to n squared? We can also simplify this further. And we can clearly see that this is false, because the left-hand side is not greater than or equal to the right-hand side. Okay, so now we can go and do 1b, which is n pi is equal to big O n cubed. Rewrite this. What is big O? Less than or equal to n cubed. We could simplify this by, what's the value of pi? It's approximately 3.14. So is this less than this? No, so this has to be false. Okay, so now we can go on 1c. N squared is equal to theta n log 3n. Okay, so n squared, theta is just equal to 9 log 3n. Okay, so we can simplify the right-hand side by simplifying the 9, which is just 3 squared, which would be multiplied by the log 3n. And then in one of our log definitions here, we can basically swap this number with this number. So n squared is equal to n squared times log 3 here. And if you plug this part into a calculator, it's just going to equal to 1. So it's going to be n squared equals to n squared times 1, which is just n squared is equal to n squared. So this is true. Okay, so now we can do 1d, which is n cube root of n is equal to small omega square root of n. So we can simplify this. Oh, actually, we can write our equation out. So what's little omega, which is greater than square root of n? So we simplify this to n times n to the 1/3, and then this is n to the 1/2. And this is 1 over 1 times 3, which is 3 over 3. this is going to be n 4 over 3 n 1/2. So we can also simplify this to like this. So is our left-hand side greater than our right-hand side? Yes, so it's going to be true. Now we could do 1e. N squared is equal to little o n cubed. So n squared, little o is, should we have it? Oh, we don't. Little o is less than. So is n squared less than n cubed? Yes, so this is true. That one's pretty simple, so we can do 1f. ln of n is equal to little o of n. So ln of n, little o is less than n. So for this problem, we can just plug in numbers. So ln of, let's say 5, we check if that's less than 5. ln of 5 is 1.6 approximately, and is that less than 5? It is, so this is true. Okay, so now we go on 1g. 2 to the nth is equal to big O n squared. And big O is less than or equal to. So is this less than or equal to n squared? Well, actually, if we look at this, this looks like one of our definitions. So an exponential is always going to grow faster than a polynomial. So if we look back to our problem, this is our exponential and this is our polynomial. So this should always be greater than or equal to n squared. Sorry, n squared. So in this statement, it's going to be. So for this problem, you can also plug in numbers to see, just to double check your work. So we did 2 to the 5th, 5 squared. 2 to the 5th would be 32, which this is not true, so which reinforces our answer false. But just try your best to remember that exponentials always grow faster than polynomials. And then we have 1h, which is n 1.5, little omega n 1.45. So n 1.5, little omega is greater than n 1.45. So is this true? Yes, because 1.45 is greater than 1.5 is greater than 1.45. So now we can go to 1i, which is n ln n equal to theta ln n. Okay. So n ln of n, theta is just equal to ln of n. And we can plug numbers in. We could do 5 ln of 5, ln 5. 5 ln 5 is approximately 8. And then ln of 5, it's approximately equal to 0.475. So this is false. Okay, then we can do Lj, f of n is equal to little omega f of n for any function f of n. So little omega is, it's greater than, so f of n, so is f of n greater than f of n? This is just not logical, so it's automatically false, because if you were to just plug in like a number, like can 1 be less than 1? or greater than 1? No, because it's the same number. Now, if it wasn't little omega, and if it was like theta or big omega or big O, which have the greater than equal to, less than equal to, or less than equal to, greater than equal to, and then there's the equal for theta, this would be true because of the equal. But since we're doing greater than because of the little omega, this statement's false. So now we can do 1k ln n is equal to small o ln n. So ln n of, let's say, 5, and small o is less than ln of 5. So I'm going to plug this into my calculator. This is approximately 0.48, and then it's approximately equal to 1.61. So this statement has to be true. Okay, so now we can go over 1L. I'm going to write that like this. ln of n is equal to little omega n. So ln of 5 and little omega is greater than. So is ln of 5 greater than 5? ln of 5 is approximately equal to 1.61, and this is false because that is not true. So now we can do 1m. N squared is equal to big O n cubed. So is n squared, what's big O again? Less than or equal to n cubed. Yes, so this is true. 1n cubed to the nth is equal to big O n squared. Sorry, did I say that? Okay, I don't know if I said that wrong, but this is pi. Simplified to 3.14 approximately. Big O is less than or equal to, and is that less than or equal to n squared? You could also plug in numbers for this, so I'm going to plug in, just going to plug in 2. So 3.14 squared, 2 squared, approximately 9.86. So this is false. Okay, now we can do 1o, 2 to the square root of n is equal to small o, 3 to the nth, 2 square root of n, small o is, let me see, less than. I'm just going to plug in another number again for this. 2 to the square root of 2. It's approximately 2.67. 3 squared is 9. And this is true. 1p 5n is equal to big omega n to the 5th. And big omega is greater than or equal to. And if we look at this, actually, this is an exponential and this is a polynomial. And remember, an exponential always grows faster than a polynomial. So technically our left-hand side should always be greater than our right-hand side because this is the polynomial. So this should just be true. But if you want, you can also plug in numbers to see. But just be careful because you kind of have to make sure you plug in a big enough number to be able to tell if it's growing faster or not. So then we have 1q. So 2 plus sine n is equal to theta 1. So whenever we encounter theta of 1, this just means that we're looking for something that doesn't grow or get smaller. So let me actually pull up Desmos and show you a visual example. So if we had sine of x, we can zoom out and tell that no matter what, this graph does not go past -1, the bounds of -1 and the bounds of 1. And then if we just add 2 to that, it's just going to shift it upwards, but the graph itself does not grow or shrink at all. So this just, let me go back. So this just proves that this is equal to theta 1 because it doesn't grow or get smaller. It stays within bounds. And so like cosine would also work. I can show you that as well. So we did cosine of x. Like if we zoom out, it's the blue. The graph never gets bigger or smaller. It stays within its bounds. So this would also be true, but tangent of x wouldn't work because tangent, let me go back. Because tangent of n in this case would equal to sine of n over cosine of n. And if cosine were to get too close to 0, tangent could explode to either infinity or negative infinity. So tangent would just never work, but sine and cosine will always be true for that. So in this case, it's true. And then let me pull up my questions. Okay, so we have 1r and 1.4 is equal to theta and 1.45. And so this one is pretty simple. Is this equal to this? No, so it's false. And we finished problem number 1.